So recording started. Welcome everyone to Developers Meeting on Sunday the 13th of August 23. And first I give over to Ido for software development. And then I think we see something from David.
Yeah, so let's actually start with David.
Okay.
Sure. Yeah, you're hearing me okay, yeah? It'd be a little bit sad if you couldn't, if I'm doing an audio demo here. Yeah, so just to kind of recap, sorry to repeat myself, but we're testing these MEMS microphones with this audio hub. It's like Infineon is the manufacturer, but they make decent MEMS microphones. These little tiny microphones you can see plugged into here. So we've got two to test. One's newer than the other, so designing some scripts and gathering some data using these mics. So I'll report on those on that as soon as I can. I'll just share my screen because I've got a session open here. Okay. So the mic is this audio hub thing is really nice. I mean, you can just plug into the Orange Pi, but I've got it set up on my Windows machine here at the moment. But I mean, there's no problem working with the Orange Pi. So, so I did some kind of basic recording. So just clicking my fingers. So I'll play that one first. And what I want to do is just record some audio signals from the mic to file, and then do some stuff with it, look at spectrograms, and then do some like basic direction of arrival stuff. So I recorded me clicking my fingers just up close to the mic. If this works. Let's have a look. Some audio. Oh, I've got the wrong device. Just bear with me a minute. All right, I'm just going to close this down, open it back up. Let's try this one. All right, that's working now. It's playing. So yeah, that's just me snapping my fingers. I can look at doing stuff like spectrograms. So you can see the time domain view here of the left and right channels, channel 1, channel 2. The same MEMS microphone plugged into these on each of the channels.
Nice overlap.
Yes.
Yeah, you can look into the time frequency plots, so you can see spread of energy across frequency, and along the x-axis is time, and then you get magnitude as represented as color. And we can do things like cross-correlation.
One question, David. Can you scroll back? Can you scroll back to the spectra?
Sure.
Yeah. Is it? Can you say from that plots that your snipping finger was closer to channel 2 than to channel 1? Could you say that?
It was actually. I think it was closer to channel 2. Yeah. It's difficult to say from this plot because they're both omnidirectional microphones, and there really isn't that much difference in spacing between the microphones. I don't know if you can see when I showed you, but they're about 2 centimeters apart. So the time, the level difference you get between the mics is not that great. But there'll be a time difference. So we can do something like a cross correlation. This is a really simple approach, but take the peak and then just look at the doing a kind of cross correlation between the peak of the channel, looking at a time lag between those. So you can see from this, it was out, I was clicking my fingers about 40 degrees off to the side of the center point. This is a really simple way of doing it. There's other algorithms we could look at as well, but this was just really just to kind of give me some confidence that things are working just as an initial test. I mean, there's different ways of doing a cross correlation. You can do it in a frequency domain as well. So as one of the common algorithms you can use for that is called GCC FAT. So it's generalized cross correlation. And I think this should work live, hopefully, he says. No, it's not showing up as a device. I'm just wondering whether it's because I've got Discord open. So let me try this again. But I made some recordings as well. So another idea is to test these with these microphones, on known sources that have a known sound power output, at known distances, and see what we get in some tests. So I did some work on recording some of the environmental sound around this area. And then, you can use, you can see what's in the area. So one of the recordings I made, we had a helicopter in the area at the time. It's about 3 nautical miles away. So we can work out and find out what the sound power output of a helicopter is, and then, I could definitely pick it up on the microphone, but you could do some little tests like that, I think, with known sources, and we could look at further distances and planes and things like that. But
so you have already a recording of that helicopter?
Yeah.
Okay, cool.
It's that's the time frequency plot spectrogram. So you can see some of the. I don't know whether you'll be able to hear the sound if I play this, but you might not be able to. Just tell me if you can't, but I won't bother going any further. But I'll play it now. You hearing that?
Not much.
No, there's
Yeah, maybe I'm probably the best thing for me to do is to write something up about it, put it on GitHub with the recordings, and then people can go and have a look there.
Can you increase the volume and store it as a tagged file, like with increased volume?
I can maybe try. I don't know whether it's streaming this through Discord or whether it's just coming through my mic.
Yeah.
In which case it's probably not very good, but
there's something.
It's pretty noisy here.
Yeah,
it's pretty noisy here in the day. I've got a helicopter on this recording, but also I've got a railway, a train track maybe about a mile away, so we could. It's in view in this valley where I'm living, but we picked up some of the train the recording as well, so we could look at that sort of thing. But yeah, I started writing an article as well, and doing some analysis on case reports. So I'm a bit all over the place here. I've got quite a lot to talk about. But is there any more questions about the mic stuff?
So the idea at the end is to have a neural network that can learn from such samples, to learn what a helicopter is and at what distance, what directions, and so forth.
Yeah, I mean, I see that as a good goal to aim towards. I think there's quite a lot of complexity in obviously getting to that stage. So I thought initially we could just keep things simple and have it just as audio as another data point to record when there's an event, and that's determined by the fisheye camera.
Until we get
there's
a significant correlation between your audio
yeah,
files.
yeah. We could gather a lot of data, and then we could do all the stuff that requires for machine learning and all that. But initially, maybe even record sound pressure levels, or record some audio to file when there's an event. So we have that extra data point.
So in this case, the distance between the baseline between the two sensors, the two MEMS, is 2 centimeters, rather low. What would you suggest? Putting in
No. We can make a better, wider distance.
David, what would you suggest?
We could look at a wider distance than that. I mean, that's a fixed distance because of how the structure of the audio hub thing that these MEMS are plugged into. But I think the idea eventually is to build our own little PCB with these MEMS on. So drawing on Boyan's experience in that regard, and then we could look at spacing them a bit further apart if we wanted to. But I mean, there's different configurations we could look at. I mean, we could just keep things simple and just have a single mic on our first version of the audio sensor suite, if you like. Keep it really simple. Get things like weatherproofing right. Making sure it's what we design is going to be
making it weatherproof on the one hand, and also not inducing airstreams and hisses from wind that breaks off some edges. So we don't want to induce new noise.
No, we can put some filters, and stuff like that, and weatherproof.
Yeah, of course we need a baseline of no noise. If you have access to a room where there's no noise or white noise, then you can calibrate it to the internal setup configuration of the sensors.
Yeah, I mean, in the days of SkyHub, we looked at that. I can't remember what it's called now. It's like it's a USB mic, but
you were talking about a cloth that I think it was 2 years ago or 3 years ago even. Remember the cloth?
Yeah, it's like a acoustically transparent cloth, but it's got good weather protection properties, so you could put some of that cloth over the end of the enclosure, the mic enclosure, to protect it
against wind and hiss.
There was a really good project, so it's still going on actually. It's a New York City Sound project. I think there's a lot of useful ideas and things we can draw from their project. They designed their own little enclosure for imams that they used, but theirs are still out and still being used, and it's been about 2 or 3 years. So they've got these audio sensors spread out around New York City. I think there's about 40 or 50 sensors, and they've published on this work, so they've got a lot of experience that we could draw on, I think. I'll see if I can find it actually.
If you can point me a link or so to the hardware they use or the designs they use. Okay.
Yeah, sure.
Sonic
So this is the one. Yeah, so all this is open source, I believe, so you can get the designs for this, but there's a little box, they've got a Pi inside. You can't really see, but there's a little protruding arm with a windshield, and the mic, the MEMS mic is within that arm. I'll see if I can get a better picture of it.
But this is a standard windshield that you see on many mics, is it? Or is it a special one? Because the normal mics, if there's rain, they suck like a foam. Yeah,
we're going to have to think of that. I mean, maybe replace it with some of that fabric.
Oh, yeah.
So, yeah, they designed a PCB. There's a little MEMS. They're tiny, these things are, but and then it sits on this, and they provide the 3D printer files that you can.
What is this shield for on the side of this little enclosure? This uprising.
Yeah,
what is it for?
I think that's just a little lip for protecting for water runoff, I think. I need to read through it again, but yeah, I think it was just for kind of helping with.
Horizontally?
Sorry?
Is this mounted horizontally, not vertically?
Yeah, it's horizontally.
Okay.
You know what we can make on a flexible PCB? So you can just glue it on a whatever enclosure someplace.
Okay.
Okay.
So that's obviously it'd be the other way around, so the water would run off. So it's upside down at the moment, so you can see inside the box here. But yeah.
So there's a rain shield above the sensor, and there's a wind shield around the sensor.
Yeah, that's right.
Basically.
Yeah.
Okay.
But with these, I think they had they placed them in New York, and a lot of the time they're placing them, on the side of on a ledge of a window ledge of a building.
Mm-hmm.
Yeah.
So the backside is of no interest.
Yeah.
Could we point them, let's say, vertically up, and let's say on a little elevated, let's say, stick or so? Now maybe not, because that induces swing in the wind. So that's something that is robust enough, let's say a couple of centimeters outside of the box. And
why outside of the box? I mean, on the top of the box.
On top of the box, yeah. Yeah. So like a little short antenna, but shorter than an antenna, because we do not want to have something induced there.
Yeah.
And then make something like a rain shield and a wind shield. And these MEMS are two-dimensional. They're little squares I've seen, right?
Yeah, they're tiny.
No. On a bottom of the board, you have just a little hole. You see on a right side, you have a little hole Right there, you see, little hole.
This is the
So this is actually sound input, sound wave input.
this
Just a little hole.
This little hole.
Yes. So this is only we need to cover.
David, please,
And,
Of course, electronics. We can you can put some like a locker or something on a top of electronics just to protect electronics. But we need to cover just this little hole. You see on the right side, if you can magnify on this is it. This is
so
actually
David,
sound hole.
Yeah, okay, got it. David, please explain us. If there is a sensor that has a hole underneath in the PCB, that means that the characteristics of the microphone is outside, away from what we see on the right side. So it goes away from the hole, right? What is on the opposite side?
this one here.
Yeah, how's the characteristic of the microphone, the sensitivity range and so forth?
Ah, sorry, yeah, this one. Yeah, it's really good actually. I mean, you get really high performance for something so small. I mean, it's a good.
Richard, this is not. You can't compare with the traditional microphone or
but still
condenser microphone.
Yeah, I get it, but still you can see the spectrum, and the range.
Yeah.
I don't know.
Yeah,
I don't
so,
know
I mean,
the correct term for this, but the characteristic of a
Ma'am.
microphone is mostly explained like a bulb going away from the microphone. How is this called?
You're looking for this frequency response.
Frequency response.
Let's have a look. See if there's any plots. There's some plots here. This sort of thing. Yeah.
Yeah.
This is only true for one direction, away from the sensor through the hole. Is this true?
Yeah.
What about the other side? Or is the
Don't mention the other side.
so there is none.
Doesn't matter.
It is just in one plane only, and let's say
Yes.
to the right, away from the board, through the opening, through this little hole, just on that side
Well,
of the
it's like-
hole.
Yeah, it's omnidirectional pickup, so it picks up all the way around the mic equally, supposedly, but whether it does that in reality is, I mean,
But
the
you-
higher frequency you
But you
get, the
get my
less
point,
that'll-
David, that the things behind the hole on the other side with the same sound energy would look different than from the other side. when the
No.
hole is-
Don't mention Richard. Don't mention backside. Don't even. This is.
So in this
doesn't.
case, it is not omnidirectional, it's just hemispheric.
You have
No, it's not.
only one direction on a bottom
No,
from
but-
this hole.
The problem is it is
From
sensitive.
another-
It is sensitive in all directions, but we do not have an idea about its sensitivity in all directions.
We can do some tests, I think, to try and determine that. I mean, this gives you some decent information, but it depends on frequency as well, doesn't it? I mean, at lower frequencies, something
So
like that wouldn't
if this
impede it.
is the measured these graphs that we have seen, if this is measured away from the sensor facing the whole side, if this is the case,
Yeah,
Yes,
I think
and we
it's
do not
usually
know what
made
the
out
other
of it.
side is, and maybe we don't even care because of the setup of the sensor, we cannot even rely on what we have to make our own graphs about it on the back side of the
You
sensor.
know,
But the question is,
Richard.
if we put the sensor and deal it as a hemispheric sensor, just take a second one on the other side and put just a shielding in between them. And
No.
then-
Do not put this in equation of backside. You don't
Boyan,
even
you don't,
mention.
Boyan, you don't get the point. My question is,
I do have a point. You have only sound from one side, from the bottom of the board, where little hole is, like a 1 millimeter or
see, this
something.
is not true. This is not true
What you talking about?
because it's an omnidirectional sensor. it also receives from the back side. So if you have a sound on the other side of the sensor, it will still hear it.
We don't need to worry about it.
Yes,
by
we do.
design. No. This will be covered. We need to worry only on a bottom from the front of the sensor, MEMS sensor. That's all we need to worry about it.
David, do you understand what I mean?
Yeah, I mean, it's frequency, it's complex, it's frequency dependent, but we can do some tests. And also, worrying about weather is...
Hold on, let me find the data.
This is an IP57 MEMS, so it's pretty decent. I mean, you don't... in terms of water ingress protection, it's okay, yeah. But I think we can do some tests and see. I think it's omnidirectional. Obviously, we have it on a PCB. It's going to have some impact, the PCB, on sound entering the port. But that'll be at really high frequencies, where the wavelengths are shorter than...
I really ask myself why they decided for that diameter of the hole. And could it be it's a compensation so that the omnidirectional feature is really omnidirectional, so to compensate for the other side? You know what I mean?
Yeah, they've actually written a paper and done some acoustic tests to kind of validate this design. I think they were looking at a high frequency that they wanted to try and capture on these sound sensors, and then just kind of worked towards that frequency, and everything below should be okay. So, but I need to look back through there. They've had about 5 or 6 publications on this. So.
Okay.
Yeah.
So okay, yes, you can make your own tests. How about the omnidirectional feature? And calibrate it along that line. My question was just, shall we, if there's a huge difference, let's say on both sides, could be, we don't know yet, but if there is, why not take 2 MEMS and put them hole to hole together, but put some dampening in between, so that we just use, let's say, both of them, sync them, and have a
Richard, let me. Can I explain you something? If you're talking about MEMS sensor microphone, you're not talking about traditional microphone. You know what I'm saying?
Yes.
It is different technology.
Yes.
Do you understand what I'm saying?
Yes, I know. So, for example, Bojan, if you just take the MEM itself, okay, it certainly has kind of pins on the underneath it to solder it on. Okay, true? Yes. So you have 2 different sides. You cannot say that a MEMS is similar on both sides. So there must be a difference in sensitivity on both sides.
No. This is a layer of sensor material, just on a top, on a one side,
only on
not
one
on
side.
A both side.
Yeah, exactly. See, and that's why you have a different behavior, sensitivity on the one side than on the other side. No.
But we are capturing.
So, Richard, but let me help you. Richard, Bojan is right on this point. The way the sensor works is actually you have a diaphragm, and the hole only and the diaphragm moves based on the mechanical frequencies of sound.
Yeah.
So it only will come from that direction where the hole is. It will not come from the other side.
Okay, so it's not omnidirectional, but hemispheric.
No, it is omnidirectional, but it's omnidirectional from where the hole is. That will get into it will cause the diaphragm to vibrate, and that's how the microphone can capture the data.
Okay.
Let's imagine, Richard. Let's imagine sphere. So you cut on a half. So you have only one half. And this is what we worry about it. Don't worry about it bottom. Another half.
Okay, I give you a simple question. You take this sensor, you stand it upright on your table, you hold it in the air, and you put a sound emitter on the left side on a certain distance, and take the same distance on the other side with the same sound emitter, same power and so forth, same frequency, same duration. Is there a difference or is there not?
Yeah, there will be.
Exactly, that's what I'm talking about.
But again, it's not that the sensor is reading from the back. It's because the sound delay will reach the diaphragm, so you can distinguish the direction. Okay.
On one man,
But
I
MEM
got it.
it's actually a micro electromechanical system, right? That's what MEM stands for.
I know.
And it's I'm reading it. It's a pressure sensitive diaphragm etched into a silicon wafer via MEMS processing.
Yeah.
Okay.
But it's no matter how it works, Ido.
It's very important how it works.
No, because it has two sides. Okay, two different sides. And this was my whole question. It was about, is there a two-sided way? Is it that the sensitivity on the right side is different from the sensitivity on the left side? Just because how it is built, how it is set up. This is my whole question. And if there is,
Richard,
then we can either...
Richard, this sensor sensing the air or yeah,
exactly.
So it doesn't sense like any other microphone. Like this is condenser microphone. If I, nothing like that. This is not like that. It's sensing the compressing and
the
air.
Of the air molecules, yeah.
Yes, exactly.
Yeah, but you, as you already said, the MEMS sits on a part that is soldered on a PCB, and it is on one side. And because there's an other side, and this other side...
Why you mention other side?
Because it is sensitive on both sides.
No.
No.
It is not sensitive on both sides?
Just on one side. Hold on, I need to find good
Why is
example.
the hole on the other side then?
Doesn't have any hole on the other
side. That's where the air comes, and that's where the diaphragm is. So the diaphragm is exposed to the air, and that's how it feels the pressure of it.
So
but
we can seal the...
But it will...
The upper side. So if the upper side is sealed somehow, damped, it doesn't matter, the functionality is the same?
What do you mean?
So if you take this chip as it is here on the board, and you say the sensitivity is only through the hole. That's what you say, right? Okay.
Yeah.
So that means that you could, the left side, you could put epoxy on it, for example. Would that work?
Why do you need to put epoxy?
Or something that dampens.
I can tell you, if you put epoxy on the right side, the sensor will not sense anything anymore.
That's it. That's what I wanted to know. And on the left side,
Richard,
it doesn't matter.
Skip confusion, please. We can skip confusion. Let me be prepared for next Sunday to explain how MEMS working. I need to be prepared. I think that the best way, this discussion doesn't make any sense.
Okay,
we're not going anywhere. Let me be prepared next time to explain how MEMS sensor working.
You can certainly explain about how MEMS sensors work, but you don't get my point here. It doesn't matter.
No, I do have a point, but I don't think you understand.
Certainly a point, but you don't understand my point. Okay. Anyhow, it is not that important. I just wanted to know.
Yes, it is important.
About hardware, and we're talking about how to set up the microphone. I was just interested in whether there are two sides of the coin and whether these two sides are different. And if there's a difference, how can we deal about it? That's the only thing I want to discuss.
I'm going to explain next Sunday on a meeting how actually, with pictures and videos, how the MEMS works. So that's why we're choosing MEMS.
Okay,
Yeah.
fair enough.
Yeah. Yeah. I'm not prepared right now, you know.
So at the end, David, we just need two MEMS.
Well, yeah, that's still an open question. I think we could make an array of these MEMS in a future version, and then do more interesting things like beam steering and direction of arrival to higher accuracy. So you could look at different arrays for that, and there's quite a lot written about that in the literature. At the moment, we're just testing with 1 or 2 MEMS, and maybe that should be just like version 1 of the audio sensor for Sky 360, just having a single MEMS, and then if we get that out and recording data, collecting data, and while we're doing that, we could be working on version 2, which would be more sophisticated and an array where we could do more interesting things like what I've just mentioned.
Beamforming, yeah.
Yeah, I mean, also it's worth mentioning the paper by Andrew Mead and the other authors, the Galileo project. They're doing taking like a multi-band approach. They've obviously got the budget, but they've got 3 microphones, I think they were looking at. One's in the audible range of hearing, which is what our MEMS covers, like 20 to 20 kilohertz, or a bit beyond 20 kilohertz. But they've also got microphones going to infrasonic range and ultrasonic range. To me, that would be an interesting expansion of this work as well in future, having an infrasonic microphone. I think I did some analysis of case reports, which I can show you here, but so I looked at about 150,000 case reports from MUFON and NUFORC library and look at sound terms with an ontology of sound terms I'd created. And most of the terms that people use when they hear UAP sound is it's like in the lower frequency range, so hum, boom, explosions, rumbling, thunder, roar. Some have got higher frequency aspects to them, but often in these case reports I've been looking through, people would comment on being able to feel the sound, which suggests that it's kind of low frequency. So definitely infrasonic microphone would be interested in future.
Absolutely. But I have a weird question again, David. I asked you that once. What about the spectral range of a human ear? Would this curve not be kind of a correlation between the response of a human ear compared to that one, to the experiences? You know what I'm saying? Because old people, when we get older, we lose the high frequencies. So the whole spectrum shifts to the left. Okay, that's why my point of view is, if we have a lot of elderly people in this group, then of course we have more lower frequencies than higher frequencies.
Yeah, I see what you mean. Yeah, so they could be biased towards.
Could be biased, true.
Yeah.
Age, yeah.
Yeah, it's definitely something you could look at. Look at the age of the people that were reporting these cases, potentially.
At the end, we could correlate this with our data, and if there's unknowns in certain frequencies, then we can correlate this with it. Yeah.
But I'm continuing this work and going to write something up about this. It's quite interesting. Doing a lot of analysis on this and trying to come up with a lexicon of basically just a dictionary of terms that people use for describing UAP sound. You know, in the vast majority of cases, people don't hear anything at all. But there is a 15%, 10-15% of cases people do hear something.
So yeah,
did a bit of work.
there's also a study I read, I think it's 20 years ago, about people where they live and how their acoustic system, the ears, is, even the eyes, is adjusted to the surroundings. So for example, if you live in a very calm place where there is, let's say you live in the desert, the only thing you hear is the hiss of a wind. And it's a difference of when these people come to a town with a huge variety of sounds. They cannot discriminate which sound is what, because it's that their brain is not trained for that, because they came out from the desert. So that they have to learn their behavior in order to adjust to find out what is what.
Yeah, it's and when we've got something anomalous like this, people often don't have the language to
describe
to describe it. Yeah, found that they often use onomatopoeias, so words that actually kind of sound like the sound they heard when you say them. So buzz, you know. Yes, but it's a long way to go, but it's a start at least. I mean, I didn't really prepare a great deal to show today, but maybe Bojan can.
This following week, Dave, we're gonna have lots of meetings if you have time. I need to be more prepared.
No problem. Yeah. I'll do some more tests on the mic. We can get together and then
okay.
Try and move things forward. I don't think it's going to be all that difficult to, acquire the signals and process the signals. The software side of it's going to be straightforward, I think, but it's the actual design of the PCB and making sure it's weatherproofed and all of that sort of stuff. And it's going to be the challenging part, I think.
Beautiful work.
Cool.
Awesome.
Yeah.
Awesome.
Cool.
Thanks, David. Cool.
Thanks.
Yeah, so I actually have to go in about 10 minutes. Katja needs me, but I was thinking with Richard how to change this meeting to be a bit more interesting for the community and also more productive for us. And I had kind of an idea. Maybe we can start discussing what we want to work on and what we need for a lower version, and kind of have more focus around that and really make the meeting around more like a work session when everyone is here, so everyone is on the same page. And I wanted to know what everyone feels about that.
I think it's good.
I'm sorry?
I was just saying, I think that's a great idea. You could have like a specific amount of time portion to demos, and then the rest of it could be like a work session. Yeah, that'd be great.
Yeah. We have very little to demo that we noticed in the last several weeks, we lose also some focus on the lower, and I'm trying to bring it back as well. And also it's a very valuable time because, again, all of us here, we can actually discuss what really needs to be done, then try to demo and stuff like that. Well, what do you think, Fabio? Do you think it will work for you?
Yeah, I think so, yeah.
Cool. Yeah, okay. So I'm sorry. I'll leave. I just have to run and help my wife. So thank you everyone. I really appreciate that.
Thank you, Ido.
Okay, Ido,
Yeah,
bye-bye.
bye.
So what Ido was just saying is that we need a kind of a preset for the next dev meetings, so to have a kind of a workshop on a certain topic, and having a little bit prepared for. And we need to decide every week what the topic shall be of the next week, kind of. But we still can discuss it, whether we want to do it that way, because it needs maybe a little bit more work on people who present for that week. But on the other hand, we are now, let's say, a dozen active developers. If you present something every 2 weeks, I think it's doable. Yeah, okay. I would say consider it, think about it, and let's talk next week when Ido is back about it. So, actually, there's something I wanted to ask Wayne. Any chance you could get the STLs and print the first examples? Wayne, can you hear me? Okay. So in this case, that Christian is not here today. Ido just stepped out. I'm a little bit planless because I'm not prepared today. Fabio, is there anything you want to introduce today or tell us?
No, not really.
Okay, so that will be a short meeting today.
I'm just continuing my researching and trying to make something that works. So, and I've been working with Ido on and I'll be trying to help Aaron today to set up his environment if it's possible also.
And yeah,
That'd be really helpful for me. If I could just spend it'd probably take 20 to 30 minutes just to get a bearing of setting up OpenMCT and ROS2 and just kind of because I don't have a Pi or any of this actual physical station, so it just kind of helped me just get up kind of a virtual environment for that, and then kind of just go high level, go over the components, and then just kind of give me a general direction where I can start contributing, and then I can take it from there.
Okay, sure. I just send you a message on a direct message, so we can talk on the private.
Okay, great.
Hey Aaron, did you just say you don't have a Pi 5 yet?
I don't.
Okay.
I could buy one though.
No,
not a big deal.
I'm going to send you one.
Send me an Amazon link. Just send me an Amazon link, and I can buy one off Amazon.
No, I'm still having, I think 2 or 3 left here.
Okay. Yeah, if you're willing to send me free hardware, I'm all for that. But I'm willing to invest a few bucks.
No, the only thing is we have a list of landing agreements, and you only sign the landing agreement. That's it. So the hardware still stays in property of Sky 360, but it's given to you in custody for a lifetime.
Okay. Yeah, that makes sense. Just send me the paperwork, and I'll sign it, and we can move forward.
Will do. Okay. Any topic for today? Otherwise, I'd say we have just 1 hour. Either we can discuss anything besides development if you want to. Otherwise, I would say, yeah, Fabio?
No.
Okay. Okay. If there's no topic today, I at least stop recording because there's not something important to talk about at the moment. So I stop recording now,